Hi everyone. Today I will want to teach you how to make a pre-training models. This is a personal project about the vehicle document classification model. I create before by our model that I training, and right now the current performance is the 92% with only 6 errors. If you look, the test sample is so small. For the reason I think that is so big as the result, and create a pre-trained models for this for a small data set is a bad idea, I think so, but I would like to teach you how to create and who will be with this. Okay, the goal is to increase that 92% to increase 95% accuracy using transfer learning, and the target we will be have less errors. So the strategy is advanced optimization techniques, compressive performance comparison, and model selection and final evaluation. And we go to use model to test like EfficientNet, ResNet, MobileNet, and BGG16. So we go to do it. We first import the libraries normally. We go to use set memory grow for GPU. Here right now is not working. I don't know why, but I have another video that explain how to configure the GPU and you don't use CPU. Is you will be have the same accuracy, but it's more faster. So in this part, we go to create the project path, the class configurations, and the training configuration. The class, only we have three classes: a document, license, and odometers. In loading baseline results is the model that I had. That I had a 92% of accuracy. So the idea is to increase that for this in this part. And this is the here. We have four functions. That is the here or this project. That we go to try to explain more easy and faster. The load annotation is my balanced annotation. Like notice that I have final files. This indicates that I iterate through several versions until I optimize the class balance. And then we extract the class from file name and its naming convention instead of keeping labels separate. I extract the class directly from the file name. This reduces errors and simplifies the pipeline. So when it start with document, we return document. Like only we separate that classes. Uh, in create dataset from annotation, that this is all this function. I use a generator pattern for memory efficient and implement fallbacks paths for robustness and optimize for the performance with parallel calls. I explained this part. And only I will get the image path, but sometimes you know that in Linux or sometimes in Windows that will be break. And so the idea is only always use paths like this. No, only the root in string roots is like the variables. So we go to use project root. If don't exist there, we go to row path and we go to try that extract that path. Okay. When we have the path, we go to extract the class. Why? Because the file names we have like for example document slash dot slash 001, but only we have extract class. For the reason only with a stem we get the first sentence of that name. And this part is for try to reduce the errors. and create the dataset. And this AUTOTUNE is for load and process images. In load and process image, we handling corrupted images with TDF point count and normalize to and normalize to 0, 1. And in this part for the stable training and standardize the size for transfer learning. This is that I made with this dev. And then we calculate the class weights and the compute class weights. Explain this part. And how I say before, we have a small data set, and in this moment only we have 329 samples in license, and for the another two is so small. So the idea of the weights class is to put more weight in each one classes, because if it's more, we have less data, less images, and we go to put more weights. Maybe you ask why reason you don't use data augmentation, but right now this is with data augmentation. Really in document only I had like 10 files. For that reason is so small the data set. The idea, as you know, is is have one biggest data set. Okay, continue. And here create a transfer learning model. We go to use EfficientNet, ResNet transfer, MobileNet, and BGG16. In this part, we go to use data augmentation one more time, and but only for the active, is only active during training. Okay. Sometimes I make like a Spanglish, but it's okay. Then we go to classification head. The classification head is like that is a pre-training. Only we are getting one part of that model. So the idea is that you try to configure the last part of that. So this is the classification head. Okay. So then we go to make to look with the initial epochs and fine tuning epochs. And what means frozen and unfrozen? More late, I will go to explain that this part. Okay, but first we go to explain this part of callbacks. We create the EfficientNet model and we go to create callbacks. Callbacks is when the ball accuracy is not increasing, so we reduce the time and we reduce the memory use. And the train with frozen base. Okay, frozen means the weights don't change. We get the model with all that knowledge. But unfrozen means the weights can change. Okay, like we can to adapt the knowledge for documents, like to be focused only on that. And it's like a new language. First, we go to use the base vocabulary, but then we go to adapt the technical technology, the terminology. Okay, so we go to train this part here, and then we go to use fine tuning for frozen. Okay, how we go to frozen? Okay, how you know that the models have a lot of layers, but in this case we go to use only the 50 layers. But we go to freeze all layers except the last 20. That the last 20 we go to fine tuning. How we go to fine tuning? We go to reduce the learning rate. We go to divide that in 10. Okay. But we go to training with the fine tuning epochs, with the bulk validation, class weights, all of that. It's like so similar, but we go to make a less changing for look which one is better. Okay, here we go to train, and we, how I said, we use the base model that is the frozen, but then we go to unfrozen that part. But only we see that if the model, the evaluation accuracy is so low comparison with our model. Okay. Then we go to train other models for comparison. We go to skip BGG 16 and we go to skip EfficientNet because already training before. Okay, and and this part we go to use so similar, but only we go to use this, and then we go to compare it both. For example, ResNet and MobileNet, we had the same ball accuracy in this part, but if you look, we have different parameters. The size is so different. This is 10 times more bigger. The training ResNet. We go to show the creative model comparison visualization, and here we can look this part. The validation accuracy progressive. The red line is our model, so we look that the only ResNet and MobileNet is more biggest. And in this part, the model size comparison, we look that the MobileNet and ResNet is a big difference. And then we go to select the best model. In this case, ResNet is not the best accuracy, not the best model. But I say, this is like trying to automatize all, but this is not the best because how I said, MobileNet is better, is so better because it's more small and it's more faster. In this case, because we have a small data set, but ResNet with the biggest data set is more better. Okay, and then we go to see the transfer learning performance summary. In these cases, the baseline accuracy that our project is 92%, but the transfer learning accuracy is 100%. Okay, the baseline errors we had 6 errors. Right now we don't have errors. We get the target, yes, but we have two problems here. The first one is the model is overfitting right now. It's so overfitting because we have 100%, and that 100% is overfitting right now because my data set is so small. And the second one is the model. ResNet is not the bear, is MobileNet in this case. No more. And I say that in error analysis dashboard that we are creating that, and how I look which one was my errors. This is the dashboard. No, the dashboard, no, the Jupyter. And how I classificate and how to show me which one are the bad, all of that. I had the code in GitHub, but I would love to create a new video explaining how to create this. And no more. Okay, guys, this is the finish. I hope that was good for you, that my explaining function for you. And if you have some suggest or recommendation for me, I would love it to get. No more. See you.